前段时间，央视新闻发布了一则关于江门中微子实验的新闻。因为报道中使用了幽灵粒子这个比喻的说法，一些伪科学营销号趁机将中微子与鬼联系起来，引发了不少误解与争议。最近我有幸采访到一位重量级嘉宾，曾因中微子研究获得诺贝尔物理学奖的尾田隆章教授，他将为我们深入剖析中微子的科学意义，带我们了解这种神秘粒子背后的精彩故事。
We want to explain the neutrino to the public, so with very simple words. So could you please explain in some simple words how do you understand neutrinos?
Okay. Well, neutrinos are very special particles. They have very small mass, and we think there must be a yet unknown fundamental reason for the small neutrino mass. And this suggests that neutrinos could be the key to explore physics beyond the standard model of particle physics. So we are excited.
Yeah. So we know that neutrino research has already nurtured several Nobel Prizes. So what do you think is the next big question in the neutrino research field? And who is leading the field now? And when do we expect the next big discovery might happen?
Okay, thank you. In the last 25 years or so, there have been significant progress in the understanding of neutrino mass and mixings, but there are still some unknowns. They are the neutrino mass ordering. We still do not know the mass state. The third mass state, nu3, is the heaviest or the lightest. In addition, we do not know Cp is violated in the neutrino sector. We do not know the absolute neutrino mass because neutrino oscillation experiments are only sensitive to neutrino mass square differences. And we do not know if so-called sterile neutrino exist. And finally, we do not know if neutrinos are Majorana particles or Dirac particles. To me, these are the next very important agenda items for the neutrino physics. And the next big discoveries could be the determination of the neutrino mass ordering and the observation of Cp violation. And I hope that the next generation experiments, such as Juno, Hyper Kamiokande, and Dune, will tell the answers by around, say, 2030.
Yeah, you mentioned the Juno experiment. Maybe some Chinese audiences already heard about that. It's the Jiangmen Underground Neutrino Observatory. So how do you comment on the work and progress of the Juno experiment? And what is the possibility of a breakthrough in this experiment?
Yeah, thank you. Well, in fact, I think Juno is doing very well. They will start the experiment rather soon. And as I mentioned already, Juno can be a very important experiment to tell the neutrino mass ordering. In addition, we expect to know the neutrino oscillation parameters much precisely through the data from Juno. So, the neutrino community is eagerly waiting for the Juno results.
Yeah, we all expect some good news from Juno. Let's talk about the future applications. In many science fiction works, we see the concept of using neutrino as a means of communications. But is there really any serious research conducted on this possibility now? Or what do you think of its possibility in the future when the technology is more advanced?
Okay, thank you. Well, I do not know if there are any serious research on communications using neutrinos. Well, in fact, I am skeptical on neutrino communications because, well, let me tell why. First of all, you need to use neutrino interactions, which is very rare.
Yes.
Therefore, the number of neutrinos you have to produce for the communication must be very large.
Yeah.
Furthermore, in order to send the information, you have to send the information by the digital signals, which means that you have to switch on and off the neutrino beam very quickly.
Yes.
I think we cannot send the signal with gigabit speed with neutrinos.
Yeah. Yeah.
The only method to produce such neutrino is to use high energy accelerators, and you have to develop a very high intensity accelerator, and you need a lot of electricity to operate it.
Yes. Sure.
And nowadays, we must think seriously how to minimize the use of unnecessary electricity to prevent a global warming.
Yeah.
Therefore, my conclusion is there might be no merit to use neutrinos for the communications.
Is there still any possibility that we use neutrino for something? Maybe not communications, maybe some other applications?
As far as the application to our daily life is concerned, I'm afraid I don't have any idea. However, some of the neutrino properties should be very useful to understand astrophysical phenomena.
Yeah.
Well, so far, physicists have been observed solar neutrinos in detail, which confirm the energy generation mechanism in the sun. In the future, by detailed studies of neutrinos passing through the Earth, we may know the interior of the Earth, and already neutrinos are playing significant role in understanding the cosmic ray acceleration in the universe. So, this way, I think neutrinos are useful.
Yeah, so maybe someday we can build a very giant CT machine for the Earth or even for the Sun. We can scan the interior structure of these celestial bodies with neutrinos.
Yeah.
Maybe. Let's hope so. Thank you. Thank you, Professor. It's a very enjoyable meeting with you today.